Hello everyone and welcome. My name is Sunny and I'm going to show you a tutorial of the software called KNIME. What is KNIME? KNIME is one of many softwares which allows you to run any kind of machine learning algorithms such as linear regression, k-means clustering, so on and so forth. Um, the interesting thing about KNIME is that it is a visual programming based software, which means that there is no requirement of coding while you're writing your machine learning programs. Right, so let's get started. You can download KNIME from their official website. The link is provided in the descriptions. You can check that out. So once you open KNIME, you will get an interface, something which you can see on your screen. So as you can see, it is having multiple windows. So for example, there is a window named as KNIME Explorer, then there is a workflow coach, then node repository, then there is the main window, main project window, description here, console, and outline, right? So there are multiple windows over here, and probably if you're starting KNIME for the first time, you will see something like this, right? So let's get started. I'll demonstrate two algorithms over here for this video. One would be an unsupervised learning, the other would be a supervised learning algorithm. So for the unsupervised learning, I'll be using k-means clustering, and for the supervised learning, I'll be using linear regression. The data set which I would be referring here will be OULAD dataset, the link of which is given in the description below in the video, right? So yeah, let's get started. So in order to start a new project, what we need to do is you can go ahead over here and click on a new KNIME workflow, right? So new KNIME workflow will host everything that you do, right? Now, once you do that, you will be asked to name your project. So I'll say project one and click finish. So as soon as I do that, you can see that there is a blank window over here, which indicates that yeah, there's nothing that is being added to my project. And on the right hand side, you can see the project description, which is basically the title. And if there are any tags you want to add, you can add that creation date and who's the author. So yeah, now you can see this project over here in the KNIME Explorer window. So basically, all the workflow which you create in KNIME will be stored in some directory, right? So here, in this case, everything is stored in the local workspace over here, and there are multiple folders. So there's example workflows, and then under that there are multiple workflows. So now these three files, which are KNIME project 1, KNIME project 1A, and project 1, are the files which are open over here, right? Yeah, right. So this KNIME Explorer window will give you an idea of the file which you're working on and where it is stored in your PC, right? The next important window in the software is the node repository over here. You can see my mouse pointer, right? So in node repository, basically you will get nodes, right? So nodes are you can imagine them as a small bit of a small machine, a small digital machine which takes in an input and gives out some output by processing it, right? So we'll clarify this as long, I mean, once we move ahead, right? So these nodes are categorized based on the functionality, the overall functionality which they will be doing, right? So for example, this node called IO, so this section called IO has all the nodes related to reading of the file, writing of the file, any connectors or any operation related to file or folder handling, right? So for example, let's say if you are working on any ML task, you are probably working with a CSV file, right? So if you have to read a CSV file, what you need to do is you need to go into this IO section. Now click on this drop down of read, and then there you go. You get a node called as a CSV reader, right? Now there are a couple of ways in which you can insert this into your main workflow. You can either click and drag it over here just like that, or if you can double click on that, it will appear it on your screen, right? So I've shown you two methods. You can double click on any node to bring it to your workspace, or you can click and drag it there, right? So now our CSV reader is ready, right? So like I told you before, I'll be going to show you two algorithms, right? So let's get started. So if I'll double click on that, you will see that I'll get a dialog box. In that dialog box, I can specify the file name. And so for example, let's say if I choose to import one of the files called student info. It's a CSV file from the OULAD dataset. I'll As soon as I click open, you can see that file is kind of loaded over here, right? And at the bottom, you are getting a preview of the file. So you can see what rows and columns are there, right? And there are other tabs which allows you to do certain transformations to your data. So what I mean by that, let's say this column called code module is string type, right? However, if you want, you can change, or basically you can typecast that data into something else. So for example, if that's a string and you want to convert it into let's say a time, I can do that, right? Uh, so like that, you could convert, uh, not convert exactly, you could typecast one kind of data into other. So basically, let's say if you're working with numbers, you can convert you can treat an integer as a double, right? So those kind of things can be done. Then there are some advanced settings related to the memory and how the files are handled. This tab is related to limiting of the rows. So for example, in some cases, the first line is the header, right? If the header is not explicitly specified. Here in this case, you can see that header is there, but if you want to skip the first line, first X amount of lines, you can do that using the skip first lines option. If you want, you can also skip the first data rows, and you can also limit the data rows. So for example, here if I limit it to 50, you can see that it's only from 0 to 49, which is 50 entries, right? So I can do those things here. In coding, if let's say if I am working with UTF-8 or ASCII, then I could probably use that. If my program requires a special encoding, then I could probably use select one of these from here. Flow variables. Flow variables are again the variables which I would want to change during the processing of my algorithm. But for now, let's keep that as it is. Memory policy, yeah. So that's also an important setting, and this memory policy tab will be available in every node, right? So this basically says that whether you want the operation to be cached in the memory or you want to write to a disk. If you are having a low RAM, probably you want to select this option, write tables to disk, or whatever, write to disk, so that everything is stored in the disk, right? So once that dialog box is closed, I mean, you're satisfied with all the settings, what you can do is you can go here and click on this play button kind of a thing, which says run essentially. Alternatively, you can press F7 to run. So once the operation is completed, you can see that there will be a green signal. So there's this there are these three dots below every node, right? So the first one is probably the red one, then the yellow and the green one. So right now, if if I drag and drop something over here, I can see that that's red, probably because there are some parameters which are missing. So for example, here in CSV import, the file is missing. So as soon as I import a file, it turns to orange, sorry, yellow. And then once I run it, it will turn into green, right? So now this is all about inserting a node and reading a CSV file. Let's say if you want to remove the CSV file, sorry, a node, what you're going to do is you can click on that and click on delete. There will be a confirmation dialog box which you have to click OK, and that's about it. So that's how you insert a node and remove a node. Right. So now what I'm going to do is I'm going to skip to this file over here, this workflow over here, and so I'm going to basically walk you through the process of how we do k-means clustering and linear regression in KNIME. Right. Okay. So yeah, let me just increase the size of this window so that it will be easier for you guys. So okay, so first I'm going to talk about uh, k-means clustering, right? So this workflow that you see over here is talking about k-means, as you can see over here, right? And after that, after k-means, I'll be talking about the linear regression, which is here as well as here, right? So I ran it on two different files. So yeah. So okay. So let's take a look at our CSV file. So the CSV file which I was using over here was studentinfo.csv, which was exactly the file which I opened earlier. And here's the preview. So there are these many columns, row ID, then we have course module, course code presentation, sorry, code module, code presentation, ID, student, gender, region, and so on and so forth, right? And I haven't done any transformation over here. And in my memory policy, it was write tables to disk, right? Okay, so that was my file. Now, for k-means algorithm to run, what I want is I want all my categorical variables. So let me just move to that. Yeah, all my categorical variables such as gender, region, highest education, these kinds of variable to turn it into a numerical, to encode into a numerical variable. So I can, obviously I can right click on this node and select this file table to see the actual data table, right? So as you can see, this is a string, this is string, this is string, and basically, yeah, except I think two rows, two columns, everything is a string, right? Everything is treated as a string. That's why you have the symbol S over here, right? So for k-means algorithm, I need everything to be converted into a number. So basically, I'll be using some kind of a encoding to transform that, right? So yeah, so what I'm going to do is I have to then insert this node basically that is category to number, right? So now category to number again is available in this, right? So if you, let's say, click on manipulation, then probably column, transform, and then here, okay, I think it is convert and replace. Yeah. So under this section, convert and replace, you will get category to number. And if you want to go vice versa, which means number to category, that node is also available. So I had clicked and dragged it over here, and this is the property which is the dialog box that I get. So here you can see that these are the variables which were categorical in nature, and everything was converted uh, from 0. So basically, the start value was 0, it was incremented by 1, and maximum categories were 100. So all the categorical variables were encoded into the numerical variables. Flow variables, I have touched nothing. Then in memory, I have written everything to disk, right? So yeah, once we do that, we can see the process data. So for that, I need to right click on this node and I'll click on the process data, and here you go. So now we'll try and make sense of what was happening. So this was the column gender, right, where the entries were either M or F. Now that is encoded as in the form of 0 or 1, right? So 0 or 1. So you can see that after getting transformed to a number, it is encoded in the value 0 or 1, right? Similarly, for region, we have another encoding like 0, 1, 2, 3, 4, 5. Then I think it goes till 12. Yeah, maximum was 12. So from 0 to 12, which means that there are total 13 regions, right? Then then this column of highest qualification, right? So highest qualification again is encoded again as 0, 1, 2, 3, right? Based on the levels. So like that, all the all the items in each of the categorical columns are encoded into a numerical format, right? Now, one interesting thing which I would like to inform you here is that there is also an option to treat missing values over here, right? So if I kind of go back to my CSV reader and see the files, these are the missing values which are indicated with the red question mark, right? So I have chosen here to map these missing values to 0, right? So when the encoding is happening, the missing values are again converted into a 0, right? Then after that, so I have used this node called normalizer. Normalizer basically converts all the data points from 0 to 1. So here you can see the minimum value was 0, maximum value is 1, and everything else is encoded in between, right? Then there is a node for k-means, right? So all the nodes related to the algorithms will be available in this analytics section. So if you see on the left-hand side in the node repository window, we have analytics, and then we have mining. In mining section, we have all the algorithms. I mean, mostly used algorithms laid down, right? So we have Bayes learner, then we have for clustering, we have hierarchy. The popular ones are hierarchical clustering, k-means, k-medioids, right? Then we have neural network. In neural network, we have MLP, that's multi-layer perceptron, right? Decision tree. So for decision tree, we have these things. Then decision tree ensemble, right? So ensemble algorithms can also be trained using the nodes. Then again, we have miscellaneous classifiers such as KNN, right? And these are some other ensemble learnings. Then, yeah, and the linear regression is here. So linear slash polynomial regression. So the nodes could be found over here, right? So, right. So once you select k-means and drag it to this the workspace, you will get a property dialog box like this, right? So in the algorithm, k-means, you know that one of the hyperparameters is the number of clusters, right? So number of clusters can be adjusted through this option, which is number of clusters here. So you can basically specify how many clusters you want to divide your data into, right? Then what is the method of centroid initialization? So yeah, that's another hyperparameter. Usually we go with a random initialization using a random seed. But let's say if you want to change something over here, you can do that as well. this option is for specifying the number of iterations the algorithm has to do, right? And here you could select all the columns which you want to include or exclude. So let's say if I want to exclude a number of previous attempts from the clustering algorithm, I'll just select that and click on this icon to move it on the exclude section, right? So if I don't want to do that, I can click on this button over here so that everything comes into the include section, right? So yeah, so these were the two hyperparameters and the number of iterations which you can specify over here, and these are the features which will be included in the computation, right? And again, flow variables at this time I have kept it blank. Haven't changed anything, and I am writing everything to the disk, right? So once I apply, click OK, and then the algorithm will run. The result of this will be like that. So basically, in this default run, I have selected number of clusters as 4. So this is the cluster view. So basically, what you're seeing here is uh, the instances of the number of data points classified under each cluster. So cluster 0 has 6480, then cluster 1 is 8612, like and likewise, right? So, and now if you want to see the labels, the cluster labels, you can you can switch to the table view, and then for each row, you will get a cluster label. So for example, row 0 belongs to cluster 3, then row 1 belongs to cluster 2, so on and so forth, right? Now, in order to make it easily identifiable, usually people apply some sort of a color coding as well, so that visually you can see that, right? So there is a node called Color Manager. So Color Manager, and yeah, there is another way to search the nodes. So let's say if you're very sure about the workflow, what you want to do, you could type in the search bar over here. So let's say I'll type color, and I'll get the node which are which does something with color, right? So here I've used this node called as the Color Manager, right? Now, another interesting thing over here is that let's say if you want to know what each node is doing, you can click on that and read the description over here. So this is the description window, right? So Color Manager, as you can see, is used for assigning the color, right? And here you will get all the possible uh, dialog box options and what each of those option means and what kind of values you can enter there and what are the inputs and the outputs. So here you can see that there is one input port which is the table to which the color should be applied, and there are two output ports. So first one is the same table with the color information appended to one of the attributes, and the second output, which is actually this thing, is color settings applied to the input table, right? So there are two outputs over here. Now, once you right click on it and select table with colors, so which is the first output, you can see that a color code is provided over here. So there's another column which is showing you a color color coded information, right? For each row. So from there you could probably see visually that which to which cluster each row item belongs to, right? And so yeah, that's how you do k-means clustering. And let's say if you want to look at your data using a scatter plot, you can just type in scatter, and you will get a scatter plot node over here. You can drag and drop it on the main canvas, and so I'm going to delete that one. and connect the output of the column manager to the scatter plot. And once you know you specify what's going to be on the x-axis and what's going to be on the y-axis, you can right click and see the image. So for example, in this case, this is my image. Let me just change a few things over here. So let's say I am going to say that age band. Okay, let's do code module and ID student, right? So let's say once you change anything, you will get this option, uh, this dialog box saying that whether you want to, are you sure you want to change that thing? Click OK and run it again. Uh, and then image. So, okay, not really clear representation, but yeah, probably code module can change. So let's say I'm going to do region this time, and let's see what the results are going to be. Image. So yeah, so on the y-axis you have student ID, on the x-axis you have regions, and the color codes are basically the four clusters which we have identified earlier, right? So yeah, this is the final result. And let's say if the algorithm clearly, if the clusters are perfect, then you will see clear segregations and not something like this, right? But then again, let's move on to linear regression, which is a supervised learning algorithm, right? So for a supervised learning algorithm, what needs to be done is that you need to partition your data, right? So, so there are two ways in which you can proceed to this problem. One is that, so one node here is the column filter node, which I have used to select the variables. So here in this case, I imported another CSV file called a student assessment, and that is having only 5 columns, as you can see in the preview, right? So there is one called ID assessment, then is ID student, then ID date, sorry, date submitted, is banked, and score, right? So let's say I want to know whether there is whether I can predict score based on the date submitted, right? So both of them, as you can see, are integers, right? I can even change their type to double or probably long, but let's keep it at that. Probably I think I should do double over here. So a score and then a date submitted. Date submitted can be integer, right? Apply, click OK, right? And click this button, right? So yeah, now since this file is having 5 columns, I don't want to use all 5 columns obviously, so I'm going to use this node called as a column filter node, which I can find over here, and you can see that everything except for these two columns, these two variables uh, for which I want to calculate the regression are sent to this exclude section, right? And nothing in the flow variable, and I've written everything to disk, right? Okay, now I have also used this node called as a normalizer. Normalizer again is used when you want to scale your data in a range of 0 to 1. So it's basically a transformation operation on the data values, right? Then comes the most important part of any supervised learning, which is the partitioning, right? So once you type partition, you will get this node called as partitioning. If you double click on that, you will see that there are 2 parameters which you can adjust over here. The first one is the size of the first partition. So first partition is basically the training set of your data. So you can either provide an absolute number, like if you're sure that you want to train your data with 100 instances or let's say 1,000 instances, you can do so. If you want the data to be divided in percentage, like percentage of some X, then you can select this and specify the number of percentage. So for example, here it is 66%. I can also do 80% depending on my requirement, right? The second section over here is how the data should be sampled, right? So if you click on this radio button, it basically is saying that you are taking data from the top. If you are selecting this, you are basically sampling it linearly. And the most common one is the random sampling, right? So draw randomly, and I'm gonna click cancel over here because I have already selected a random sampling, right? So once you have partitioned, you can see both of them, right? So this is the first partition. You can verify this with the number of instances. So here it's 114,000, right? And the second partition is basically 59,000, right? So that's close to, yeah, 80% and 20%, right? For linear regression, you can insert the linear regression learner, which is which will basically specify how much, basically specify the parameters, hyperparameters for regression, right? So here you have included date submitted and the target variable is score, right? And nothing is excluded. So if I wouldn't have used this a column filter, I would have again excluded everything at this stage. So there's no uh, critical need of using that column filter at that stage, right? Uh, Now other things are how to treat missing values. So I can choose to ignore the rows with missing values, or I can fail on observing the missing values. So there are two ways in which missing values can be handled, right? And then basically once that is done, you can uh, train the model, and the output will be in the form of this model. But the important things are the coefficients, right? So what will be the coefficients and the standard errors for the variables, right? Now, in order to test how the algorithm has performed, we can use this node called as the regression predictor. So for every algorithm which is supervised in nature, you have a corresponding predictor node as well, right? So predictor node basically takes in inputs from the model, which is this one, and the second partition of the data. So for when you're partitioning the data, basically there are two partitions created, which is the training set and the test set. So it takes in the input from the test set and generates a score over here, right? So for this node alone, the regression predictor node alone will give you the predicted values, right? So for example, let's say the score was 0.79, the predicted is 0.768. So yeah, this has predicted the value pretty close, 0.72, 0.768, and likewise. So here 0.52, but then again 0.768. And I'm also seeing many values over here which are 0.768, and they are very far from the actual values, right? So from this observations, I can kind of intuitively see that it's probably not a good model, right? So in order to get a definite score for that, I can use this node called as a numeric scorer, and basically it will compares the reference against the predicted column and gives you a final score, right? So final score is obtained in this format. So basically for regression, we use uh, this metric called as R square, right? This is the mean absolute error, this is the mean squared error, and this is the adjusted values of R square. So R square is very less, it's very far from 1, which means that obviously there's no uh, correlation, and the regression model is not appropriate. Probably I might have to use polynomial regression for predicting. But yeah, then again, that's my guess at this point of time, right? So this concludes this presentation. So you have seen two algorithms, right, in KNIME. So first one was k-means clustering, and the second one was linear regression. So essentially, for every operation that we do with data, we have a corresponding node which can be found in the node repository section. And so, for example, if we want to take in the input data, we have this node for reading and saving the data. Then we want to write probably. Then if we want to work on algorithms, we have the section on mining where all the algorithms are available. And yeah, other things, right? So yeah, that's about it. If you have any queries, please post it on the comment section. Thank you.